So let's try some more questions on second order linear non-homogeneous differential equations. This time we are going to try or solve questions where the non-homogeneous term, which is the term on the right hand side, is equal to an exponential function of the form a times e to the power ax. Now, to solve such problems, we need to take notice of these three cases which we may encounter. So the first one is if e to the power ax does not appear in the complementary function, then we are going to establish for the particular integral yp equals a times e times a to the power x. Now, secondly, if only e to the power ax appears in the complementary function, then we establish yp equals a times x times e to the power ax. And then lastly, if we encounter the situation where both e to the power ax and x times e to the power ax both appear in the complementary function, then we establish yp equals a times x squared times e to the power ax. So let's try to solve the problems one after the other, and let's try to find the general solution of the second order linear non-homogeneous differential equation. So let's start off with this example 5. Now we are going to solve the general solution of this differential equation, y prime prime plus 3y prime plus 2y equals e to the power x. So let's try to solve this problem together. This is a second order linear non-homogeneous differential equation. So we have the differential equation given y prime prime plus 3y prime plus 2y equals e to the power x. So as we know, first of all, we are going to treat this as a homogeneous differential equation so that we make the right hand side be equal to 0. So that we have y prime prime plus 3y prime plus 2y equals 0. Now at this point, since the differential equation is a homogeneous differential equation, we are going to obtain the auxiliary equation from the differential equation. So we are going to replace y prime prime with m squared, y prime with m, and then y with 1. So 2 times 1 is still 2, and that is equal to 0. Now at this point, we multiply the coefficient of m squared, which is 1, by the coefficient of constant, which is 2, and then we want to find two numbers that when you multiply, you are going to get 2. When you add them, you are going to get 3. So we have 1 and then 2. So what we are doing is to find the roots of this auxiliary equation. So we have the factors to be 1 and 2, so that is m plus 1 and then m plus 2 equals 0. So we can have m plus 1 equals 0. We transpose 1 to the right hand side, and then we have m equals negative 1, and then we have m plus 2 equals 0. We transpose 2 to the right hand side, and then we have negative 2. So let's call this m1, let's call this m2. Now since we have two real and unequal roots, we have yc, which is the complementary function, the general solution of the homogeneous differential equation, giving us c1 e to the power m1x plus c2 e to the power m2x. That is giving us yc equals c1 e to the power negative x plus c2 e to the power negative 2x. So this is the complementary function. Next, let's try to find the particular integral. So for the particular integral, we have g of x, which is the non-homogeneous term, to be e to the power x. Now we are going to check if we have e to the power x in the complementary function. So here we have e to the power negative x, e to the power negative 2x. So you realize that e to the power x is not found in the complementary function. Now, if e to the power ax does not appear in the complementary function, then we are going to establish yp equals a times e to the power ax. So since we don't find e to the power x in the complementary function, then we are going to establish yp equals a times e to the power x. So in this case, we have the smaller a to be 1, so 1 times x is x. Now for yp equals a times e to the power x, then we are going to have yp prime to be equal to, you differentiate x, you have 1 times a is a, and then you repeat what you have again, and then for yp prime prime, we are going to differentiate this. You differentiate x with respect to x, you have 1 times a is a, and then you have e to the power x. Now we are going to plug y prime prime, y prime, and then y into the differential equation. So from the differential equation, we have y prime prime, which is a e to the power x plus 3 times y prime, which is a times e to the power x plus 2 times y, which is also a e to the power x, and that is equal to e to the power x. Now you have a plus 3a plus 2a, and that is equal to 6a. So you have 6a e to the power x equals e to the power x. Now comparing coefficients of e to the power x, we are going to have 6a equals 1. So you have 6a equals 1. You want to find the value of a, so you divide through by 6, and then you have a to be equal to 1 over 6. Now from the particular integral, we have yp equals a times e to the power x. So yp equals a, which is 1 over 6, times e to the power x. And you know that the general solution of the differential equation is given by y equals yc plus yp. Therefore we have y to be equal to, now for yc we have c1 e to the power negative x plus c2 e to the power negative 2x. So c1 e to the power negative x plus c2 e to the power negative 2x, and then plus yp, which is 1 over 6 times e to the power x. So this is the general solution of the given differential equation. So now let's move on as we solve example 6. So for example 6, we have the differential equation 2y prime prime minus y prime minus 3y equals 5 times e to the power 3 over 2 times x. So let's try to solve this differential equation. So we have 2y prime prime minus y prime minus 3y equals 5 times e to the power 3 over 2x. So the first thing is we need to treat this as a homogeneous differential equation by making the right hand side equal to 0. So it becomes 2y prime prime minus y prime minus 3y equals 0. Now let's try to derive the auxiliary equation. That is, we have 2m squared minus m minus 3 equals 0. Now we multiply the coefficient of m squared and then coefficient of the constant. 2 times negative 3 is negative 6. So we want to find two values that when you multiply you have negative 6, but when you add you have negative 1. So we can have 1 and then negative 6, and then we can have 2 and then negative 3. So 2 plus negative 3 is negative 1. So we are going to use these two sets of values. So 2 negative 3. So we have 2m squared plus 2m minus 3m minus 3 equals 0. We factor out 2m inside of the brackets. We have m plus 1 we factor out negative 3, we have inside m plus 1 equals 0. So we have 2m minus 3, and then m plus 1 equals 0. So first we have 2m, we transpose negative 3 to the right hand side, we divide through by 2, and then we have m to be equal to 3 over 2. Again, we transpose 1 to the right hand side, we have negative 1. So let's say we call this m1 and then we call this m2. Now since we have two real and unequal roots, then we have the general solution to the homogeneous differential equation to be c1 e to the power 3 over 2x plus c2 e to the power negative x. So this is the general solution to the homogeneous differential equation, that is the complementary function. Now the next thing we are going to do is to find the particular integral. So for the particular integral, we have g of x, the right hand side, to be 5 times e to the power 3 over 2 times x. Now let's check the complementary function. We have e to the power 3 over 2x, and then here you realize that we have e to the power 3 over 2x. Now since we have e to the power 3 over 2x appearing in the complementary function, what we are going to do is, if you have only e to the power ax appearing, then you are going to establish yp equals a times x times e to the power ax. So this time we have an additional x in it. So we are going to have yp equals a times x times e to the power 3 over 2x. This is going to be the particular integral. Now we are going to find yp prime and then yp prime prime. So for yp prime, that will be equal to, we are going to apply the product rule for differentiation here. So we are going to select ax as one, e to the power 3 over 2x as the other. So we have ax, and then we try to differentiate this part. So when you differentiate 3 over 2x with respect to x, then you have 3 over 2, and then you have e to the power 3 over 2x plus, you select e to the power 3 over 2x, you differentiate ax with respect to x, and then you have a. So let's try to rearrange this. Let's try to present it in a more nicer way. We are going to have 3 over 2 ax times e to the power 3 over 2x plus a times e to the power 3 over 2x. So that is yp prime. Now for yp prime prime, we are going to differentiate this function. So yp prime prime, that will be equal to, we are going to select first 3 over 2 ax, and then we try to differentiate e to the power 3 over 2x. So that's going to give us 3 over 2 e to the power 3 over 2x, and then plus, we have e to the power 3 over 2x. We differentiate 3 over 2ax with respect to x, and you have 3 over 2a, and then we move on to the second term. So plus, we are going to have 3 over 2 times a times e to the power 3 over 2x. Notice that a here is a constant. So trying to simplify this equation, we are going to have 3 over 2 times 3 over 2. 3 times 3 is 9. 2 times 2 is 4. So 9 over 4 times ax times e to the power 3 over 2x plus, here you have 3 over 2a times e to the power 3 over 2x. Now here you have 3 over 2a times e to the power 3 over 2x. here you have 3 over 2a times e to the power 3 over 2x, so we can add the 2. So if you have 3 over 2 plus 3 over 2, basically the denominator is the same, so you add the numerator. 3 plus 3, we have 6, and then 2 goes here once, 2 goes here 3 times, so you have the final answer to be 3. So instead of having 3 over 2 times a times e to the power 3 over 2x, we are simply going to have 3 after adding the 2, so 3a times e to the power 3 over 2x. Now we call this yp prime prime. Now from the differential equation given, we have 2 times y prime prime, so 2 times 9 over 4 ax e to the power 3 over 2x plus 3a e to the power 3 over 2x minus y prime. We have y prime to be 3 over 2 ax e to the power 3 over 2x, and then plus ae to the power 3 over 2x, and then minus 3 times y, which is a times x times e to the power 3 over 2x, and that is equal to 5 times e to the power 3 over 2x. Now let's try to expand and simplify. So we multiply here 2 across. Now 2 goes here once, 2 goes here 2 times, so that becomes 9 over 2. So 9 over 2 ax e to the power 3 over 2x plus 2 times 3 is 6, so 6a e to the power 3 over 2x, and then minus 3 over 2 ax e to the power 3 over 2x minus, so the negative affects this term, so minus ae times 3 over 2x, and then you multiply negative 3, so negative 3 ax e to the power 3 over 2x equals 5 e times, or e to the power 3 over 2x. Now let's try to see if we can cancel out like terms. So here we have 9 over 2 ax, we have minus 3 over 2 ax, and then we have minus 3ax. So 9 over 2 minus 3 over 2, because the denominator is the same, we work out with the numerator. So 9 minus 3 is 6, and then you know 6 divided by 2 is 3, and then 3 minus 3 is 0, so we can cancel out 9 over 2, negative 3 over 2, and then negative 3, and then we are left with 6a, negative a, and then 6a minus a is 5a, so 5a, take notice of the coefficient of 6a and then a. We have the coefficient to be e to the power 3 over 2x, and that is equal to 5e to the power 3 over 2x. Now since we have coefficients to be the same, we can simply compare both sides of the equation. So here we have 5a, to be equal to 5. We divide through by 5, and then we have a to be equal to 1. So a is equal to 1. Now if a is equal to 1, what this means is that we have yp to be equal to 1 times x times e to the power 3 over 2x. Therefore we have yp to be equal to x times e to the power 3 over 2x. This is yp. Therefore the general solution to the differential equation, which is given by y is equal to yc, which is c1 e to the power 3 over 2x plus c2 e to the power negative x plus x times e to the power 3 over 2x. This is the general solution to the given differential equation. Now let's move on as we solve the last example. Now to the last example, we are going to solve the differential equation y prime prime plus 2y prime plus y equals 3 times e to the power negative x. So we have y prime prime plus 2y prime plus y equals 3 times e to the power negative x. So we treat this as a homogeneous differential equation, so that we have y prime prime plus 2y prime plus y equals 0. We generate the auxiliary equation, that is m squared plus 2m plus 1 equals 0. We multiply coefficient of x squared by coefficient of constant, we have 1. Two numbers that when you multiply you have 1, when you add you have 2, that's going to be 1 and then 1. So 1 plus 1 is 2, 1 times 1 is 1. So we have m plus 1, m plus 1, that is equal to 0. So we have m equals negative 1, m equals negative 1. So we have this to be m1, m2. So it means that we have m1 equals m2 equals negative 1. So we have two real and equal roots. Therefore, we have the complementary function, the general solution to the homogeneous differential equation, to be c1 e to the power m1x plus c2x e to the power m2x. So that is equal to c1 e to the power negative x plus c2x e to the power negative x. That is yc. Now for the particular integral, we have g of x, the function on the right hand side, to be 3 times e to the power negative x. Now looking at the function g of x, you realize that we have e to the power negative x, and from the complementary function we have e to the power negative x and then x times e to the power negative x. Now the moment we have both e to the power negative x and then x times e to the power negative x in the complementary function, then we are going to establish yp equals a times x squared times e to the power negative x. So from the third case, if both e to the power ax and x times e to the power ax appear in the complementary function, then we have yp equals a times x squared times e to the power ax. So that is exactly what we've done here. So we are going to find yp prime and then yp prime prime. So for yp prime, we are going to select ax squared, and then we differentiate e to the power negative x. We have negative e to the power negative x, plus we select e to the power negative x. We differentiate ax squared. We have 2ax. So we are going to have yp prime equals negative ax squared e to the power negative x, and then plus 2ax e to the power negative x. Now for yp prime prime, you are going to differentiate this function. So first we select negative ax squared, we differentiate e to the power negative x. We have negative e to the power negative x plus we have e to the power negative x. We differentiate negative ax square, we have negative 2ax, and then plus this term, so plus we select 2ax, we differentiate e to the power negative x, that is negative e to the power negative x, and then plus e to the power negative x, we differentiate 2ax, and then we have 2a. So let's try to expand and simplify. So we have this to be ax square e to the power negative x minus 2ax e to the power negative x minus 2ax e to the power negative x plus 2a e to the power negative x. Let's try to simplify this. Finally, we have ax square e to the power negative x minus 4ax e to the power negative x, and then plus 2a e to the power negative x. So this is yp prime prime. Now from the differential equation given, we have y prime prime plus 2y prime plus y equals 3 times e to the power negative x. So y prime prime, that is ax square e to the power negative x minus 4ax e to the power negative x plus 2a e to the power negative x plus 2 times y prime. Y prime, we have negative ax square e to the power negative x plus 2ax e to the power negative x plus y, which is ax square e to the power negative x, and that's equal to 3 e to the power negative x. So we are going to expand. We are going to have ax square e to the power negative x minus 4ax e to the power negative x plus 2a e to the power negative x minus 2ax square e to the power negative x, and then 2 times 2, so plus 4ax e to the power negative x, and then finally plus ax square e to the power negative x equals 3 e to the power negative x. Now here we have ax square, we have negative 2a x square, and then we have ax square. So ax square plus ax square becomes 2ax square minus 2ax square, so it goes to 0. And then we have negative 4ax, and then plus 4ax, so this also goes to 0. We are left with 2a e to the power negative x. So 2a e to the power negative x equals 3e negative x. So e to the power negative x is common here, so we basically have 2a. We basically have 2a equals 3. We divide through by 2, and then we have a to be equal to 3 over 2. Therefore, if a is equal to 3 over 2, then we have yp to be equal to, we are going to have yp to be equal to 3 over 2 times x squared times e to the power negative x. This is going to be the particular integral. Hence, we are going to have the general solution for the differential equation to be y equals c1 e to the power negative x plus c2 x e to the power negative x plus 3 over 2x squared, 3 over 2x squared e to the power negative x. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.